Right. Duly noted that this is a circuit problem, and you're not going to see a circuit problem this year on your AP test. It is a ranking problem, and ranking problems are something I think would be easy for them to put on this crazy test for taking this year with the coronavirus stuff. So let's talk about what we would have to do. So ranking problems are always the same thing. It's say, which one has the most to the least, rate them all in there. Be aware almost always there's an equal sign between two of them, right? It's almost never just A, B, C, D. It's boom, okay? So it says here, in which of the three circuits above, the batteries are identical, the light bulbs are identical, there's a resistors, right? This is connected to a battery in circuits 2 and 3. Light bulbs are connected to the battery in different ways as shown. Look, the wires. So, and this one that comes out, this one it comes, where's mine? There it is. This one comes out of the battery, goes through this one, then through this one, then back. This one it goes through this one, or it can go through this one, but it doesn't have to go through both, right? So in this circuit up here, this circuit right here is battery, one resistor, and back home. This is battery, resistor in series, and then back home. And this one right here is battery, resistor choice 1, resistor choice 2. Okay, and so this is your straight up, that's your thing. Now again, we didn't spend enough time on what batteries and light bulbs look like. They'd be out of your desk, but that's what they're asking essentially right there. Okay, so which one has the rank the magnitude of the potential differences across each of the light bulbs? Okay, so I look at it and go, wait a second. In this one, an electron coming out of this wire has to go through this light bulb and go back home. So it's going to use all its voltage here. So this is a 6-volt battery, is what it looks like. It uses all 6 volts going through this light bulb. An electron going this way through this one has to lose some of it here and then some of it here. If these are the same light bulb, in fact, it's going to lose 3 through one and 3 through the other. So in each one, it's going to lose less than it would in this situation. And in this one, an electron coming through this could go through this light bulb, come back out the other side, and go back to the battery, right? It wouldn't go through 2 light bulbs. So therefore, I lose 6 here and 6 here. So the answer to the question is, I get my pen back, A equals B equals C, which is greater than, oh, did I do that right? No. A equals D equals E, because all those light bulbs will use up the whole 6 volts if it's a 6-volt battery. But B and C are equal, but are less. Okay? Explains how you determine your ranking. You're going to write something along the lines of resistors in parallel lose all the voltage, use up all the voltage of the battery. Electrons have to use up all the voltage going through that resistor. And so that'd be the same as the situation A, where there is only one light bulb. And resistor, in the situation for B and C, it could not get back to the battery without going through both of them, so it'd have to use some of its potential difference in B and some of its potential difference in C. And you can even use the word half if you like, although again, you don't have to, right? Okay, pausing. And a reminder, they're trying to warm you up to what it is you are going to be doing the next part, right? My paragraph length response is coming. The batteries start with the same identical amount of energy, usable energy, that are connected to light bulbs in circuits at the same time. In which circuit would the battery run out of energy first? So the real question is, which one is using up? Now, there's a couple ways to approach this. One, power, right? Power equals I squared R, okay? And so we've already determined in situation A, in A, okay, what do I got going on? Circuit 1. Oh, sorry, in circuit 1, okay? In 1, I got V equals IR. I got P equals I squared R, okay? So in 2, I have V equals I times 2R. So I is 1/2 of I from this one, right? I over 2, okay? So therefore, power equals I over 2 squared R. So this one here, each light bulb, plus you have a second one, right? Power plus the second light bulb, which would be I over 2 squared R. So if you did that carefully, you'd realize that this is 1/4. This is 1/4 of this one here. And therefore, you're going to end up with 1/2 the power of the first case, right? And then in 3, well, you've got the full voltage drop across there, so both of them have the same current. So you'd say, well, the power is going to therefore be equal to I squared R plus I squared R. So this one's going to be using twice as much power as the other ones, right? So this is using twice as much as P1. So circuit 3 uses twice as much as circuit 1. So which circuit would the battery run out of energy first? The one that's using the most power, right? It's going to run out of the most energy, right? Because it's building its power energy faster. So therefore, this is the one that's going to run out of energy first. Cha-chang! Which circuit would the battery run out of usable energy last? Well, 2. 2's hardly using energy at all. Okay. In a paragraph length coherent response question. Which of the following may contain equations and drawings? Explain your reasoning. Okay. So, my reasoning involves which one has the most power. Okay. Whichever circuit uses the most power will run out of energy first. And you can put it assuming they have the same energy to start with. Therefore, since circuit 2 requires the wrong word. Oh, you can put one line through it and they skip the word. So circuit 2 has half the current. It has 1/4 the power for each circuit. Each resistor. One line through it, resistor. And so now I'm going to look over here and I'm going to take this P equals I over 2 squared R. Okay? So it would have half the power of circuit 1. And I'd go P equals I squared R. And then for my last one, I would go in 3. Each would have the current in circuit 1 because they are in parallel, out of space and out of ability to write. Therefore, P equals I squared R plus I squared R, or 2 times the power. And therefore it uses energy the fastest. Okay? All right, that's it. That's how you do a paragraph length response. Again, took me 8 minutes explaining myself, writing badly, taking my time. You're going to have 15 minutes. Nothing I did here is you doing it slower than the way you do it. So, don't stare at the paper and go, oh, I got to write 5 more sentences. No, you're good. You're good. You're good. You've made all the points. Read it. Read it out loud because you're going to be sitting there by yourself. It's going to be great. You can actually pull that off. Okay? All right, here it is. So do that. So that's how you do paragraph length responses. You got questions, shoot them at me. Thoughts, shoot them at me. Again, not a great example because it's a circuit problem, but I only have 8 paragraph length responses, I think, that don't include things like waves, which we didn't cover. So I'm going to give them all to you because you need to see them all. All right.